Making a cannon that can fire in any direction is remarkably easy if you learn to use body thrust. First, let's start by making a cannonball. It can be spherical. It can be cubic. Just keep in mind that the bigger it is, the more force the body thrust will need to be able to move it later. For my cannon, I will be using a spherical part that is 3 by 3 by 3. Next, you want to raise it off the ground and smoothen all sides of it. Next, insert a body thrust and body velocity. The body thrust is what allows the cannonball to fire in the direction it's facing. The body velocity gives the cannonball anti-gravity. The body velocity will forcefully try to move the part to go at the velocity specified in its velocity property, but it can only apply as much force, to achieve that goal, as is specified in its max force property. Note, force and velocity are not the same units of measurement. The amount of force it takes to move a part of my size at a velocity of even 20 studs per second is somewhere in the thousands. That is why, in order to keep my cannonball's velocity along the y-axis unchanged, I set the y parameter of the velocity property to 0, and the y parameter of max force property to 5,000 or higher. So that it will use 5,000 force to keep the velocity along the y-axis at 0. Note that the y-axis is the axis the part travels along when it goes up and down. Thus, because the max force in the y parameter is enough to counteract gravity and keep the part's travel along the y-axis at 0, it is essentially anti-gravity. Anyway, because we don't want the body velocity to have any influence on x-axis or the z-axis, because those are the directions we want our body thrust to control completely, you will see me set the x parameter and the z parameter of body velocity's max force property to 0. The result is that it will apply 0 force to keep the velocity along the x-axis and the z-axis at 0, and 0 force is literally no force at all. So, ultimately, the part won't fall to the ground but will still travel in the direction that body thrust guides it towards along the x-axis and z-axis. If you want your cannonball to slowly drift down, you may set the y parameter of body velocity's velocity property to something negative, like -1 or -2. On screen now, I'm demonstrating the anti-gravity working to stop the ball from falling. And then I demonstrate making it slowly rise after I change the y parameter of body velocity's velocity property to +1. Note that the part is unanchored. Now, you will want to make the cannonball move in literally any direction by changing either the x or z parameter of body thrust's force property to something high enough to move the part. For mine I set the z parameter to 500. Theoretically, if the part has been completely anti-gravitied and it has no friction with the ground, then any force should be enough to make it move at least very slowly. Anyway, next, run the simulation and see which direction the cannonball goes toward. Then stop the simulation. You may rotate the part, keeping in mind which direction the body thrust made it move in before. Think of it like the body thrust is making the center of the object move towards that face of itself. And you could change the direction the object travels in, relative to the workspace, by rotating that face to face a different direction. You could even add a decal or surface weld to that side, to denote it from the rest. On screen I am demonstrating what I just said. For the next step, create a new part. Anchor it and attach it to the cannonball using surface welds, as you see on screen. After running the game again, note that the cannonball no longer goes in any direction because it's attached to an anchored part, but if we delete the anchored part it moves as usual. The most important thing to realize here is that if we can somehow delete the anchored part when the player presses something, like a button, we'd basically have a fully functioning cannon. Which is what we're here to make. There are 3 solid ways I have found to delete things: destroyer bricks, battle armor scripts, and dropping parts into the void by either letting them fall off the edge somehow, or by teleporting them directly into the void by letting them touch a teleporter that has an offset of something like -500. We can't really use any of those methods on the anchored part that's attached to the cannonball, however, because it's too close to where the player will be, and other parts which we do not want to destroy. So, later, we will parent the anchored part to another part, which we will use one of our 3 methods on to effectively destroy the anchored part. Because when we destroy an object, we also destroy everything that is parented to that object. What you see me doing on screen now is building a chamber to house the part we will destroy, the part that will be the parent of the anchored part. For coherency reasons, we'll call this part Fred. The anchored part will be parented to Fred. At this point, I was already intending for the size of Fred to be 2 by 1 by 2, so I made the interior of the chamber slightly wider and longer by making the walls slightly thinner. You don't necessarily always have to expand the inside of the chamber to be bigger than the part, but, sometimes, Retro Studio and Roblox Studio will attach 2 parts together with a weld object if the 2 parts are merely touching, even if they do not have connected surface welds. So to avoid having Fred welded to the side of the chamber, because we need Fred to fall, unrestricted, to the bottom of the chamber, I made the inside of the chamber slightly larger so that Fred doesn't even touch the side. The part that I have just made blue is going to be a door. In the next step, we will make the bottom part of the chamber a conveyor that will push Fred towards the door. I am assuming you know how to make a conveyor. Now I am making the chamber slightly taller in case we add more cannonballs and, subsequently, more Freds. Make sure all the parts of the chamber are anchored, including the door. Transparent walls are optional. Now, we will make Fred and add him to the chamber. When Fred is done, I will group Fred and the anchored part together and parent the anchored part to Fred so that he may pay child support and cover all expenses until the part turns 21. Ha, ha, that was a joke. I should be a comedian. Note that Fred is just a plain, unspecial part, despite the unique name. You could make Fred any size and color you want. There is nothing important to the design about the way that I have designed my Fred other than the fact that the size of your chamber would need to be bigger if your Fred is bigger. Here, I am grouping together Fred and the anchored part, and then setting Fred as the parent of the anchored part. Note that Fred is the green part, though I didn't officially call him Fred when I did the recording, so you'll see me name him. Gonna delete this. Now, by running the game again, we see that the cannonball flies away when we delete the anchored part. And when we run the game once more, we see that the anchored part is deleted when we delete Fred, allowing the cannonball to fly away, again. It's at this point that you might realize that the rest of this video will be spent designing a mechanism that allows us to delete Fred on command by using a button.